This program was produced by WGBH Boston, which is solely responsible for its content. Major funding for this program is provided by public television stations. Additional support is provided by unrestricted general program grants from the Corporation for Public Broadcasting and the Ford Foundation, and by grants from Exxon Corporation and the National Science Foundation.
Noon in the Sonoran Desert, southern Arizona. Temperature, 120 degrees Fahrenheit. In places, as little as an inch of rain falls all year. The air has no moisture to shield against the midday heat or retain it after dark. Deserts are the youngest of the Earth's natural environments, as young as man. Recent change in world climate has created these vast deserts where patterns of weather converge to produce that climatic accident, extreme aridity. Much of this region was lush with grass and woodland 100,000 years ago. It was engulfed by desert faster than new forms of life could evolve. But life did not vanish. The plants that could withstand the extremes have flourished. The animals that could avoid the extremes remained. Together, they populate the Sonoran with the most intricate fabric of desert life on Earth. The deserts of North America lie in the cloudless center of this view from space. They are created by three separate cycles of air and moisture. The first is a current of air moving north from the equator. It descends dry and evaporates the moisture in its path. The second cycle begins with a cold coastal current from the North Pacific. It strips the water from moist westerly winds before they reach land. And last, the remaining moisture is condensed as rain on the cool seaward slopes and peaks of the coastal mountains. The wind descends inland as a wave of dry air desiccating the land, the North American desert. It has four divisions, each profoundly different from the others: the Great Basin, the Mojave, the Chihuahuan, and the Sonoran. The Sonoran Desert meets the sea, the Gulf of California. 30 million years ago, this region was covered by a vast inland ocean. It is now a desolate beach made from the broken shells left by those ancient waters. Here, on the coast of Mexico, the desert begins. This is the core of the Sonoran Desert, one of the hottest and driest places on Earth. This winter brought 1 inch of rain, and no more may fall this year. Moving northeast, the face of the land changes. 50 miles inland, the sand rises to meet the Sierra Pinicate, a recent volcanic catastrophe. There is more rain here, about 3 inches a year. Further inland, approaching Tucson, Arizona, the mountain ranges become higher and more continuous. From the Gulf of California, the land has risen 2,500 feet to this basin, outside of Tucson. It is here that the film takes place, in a region of the Sonoran Desert profoundly different from the bleak Gulf Coast. The annual rainfall here is 10 inches. Almost half that moisture comes during winter from Pacific weather systems that blanket the entire Southwest for days at a time. It is now late March, and the last winter storm brings heavy snow to the peaks high above the desert. Snow and freezing temperatures pose few problems for the life on the mountain slopes, but below 3,000 feet, where desert vegetation begins, winter is a severe test. Many of these plants cannot recover from a continuous day and night of temperatures below freezing. Desert plants like these prickly pear are specialists in drought and heat. They cannot stand the cold. Only once in 25 years does winter weather last beyond March, but exceptional conditions can have profound effects. Unless the storm passes, the frost will not break, and 70% of these saguaro cactus could die. Only if it thaws within that critical 30 hours will the danger pass and the plants survive. Winter storms have deposited snow for 3 months on the Santa Rita Mountains, which rise near Tucson to 9,500 feet. Their upper slopes are dense with fir and pine. The winter's snowpack is beginning to melt. Thousands of feet below, the runoff follows these normally dry riverbeds to the desert floor. These arroyos run only when fed by spring melt or the erratic seasonal rains. During the coming months, the streambed life must survive only on this brief annual recharge of water from the mountains. These saguaro cactus are not dependent on the arroyos. They derive little benefit from the runoff. In winter, they receive their water from the gentle, soaking rain, which sustains them until the summer thunderstorms almost 4 months away. These 2 seasons of rain combine to nourish a zone of life more extravagant in its variety than in any other desert. Plants are the basis of all life on Earth. They bank the energy of the sun, strain the sand and gravel for water and nutrients. They provide food and shelter for the animal life of the desert. They are the beginning of the food chain. The plants here have survived the extremes of heat and aridity because of specialized mechanisms and strategies. The cactus is one of the most successful. They are colonists. As the desert spread, the cactus was ready to advance with it. They probably evolved in the tropics of Central America under local arid conditions. They developed the capacity to store enough water to survive a year of drought. They grow no leaves. Instead, their green skin carries out photosynthesis. It is waterproof, so the fluid stored within cannot evaporate. The cactus is defended against thirsty creatures, but some are safe behind the thorns. Spines offer more than defense. They help control temperature and water loss. They may even conduct heat from the plant and lose it to the wind. They break the wind's force and slow its drying effect. The smaller they are, the more vulnerable to animals and heat, and the thicker their spines. On the smallest, they even grow dense enough for shade. 1 inch high and 3 years old, This small, bristling plant grows to be the largest living thing in this desert, the giant saguaro. Like a tree, it grows tall and to a great age. It has roots, a trunk, and limbs. But as a cylindrical form without leaves, it has 1/10 the surface area through which to lose water and gather sunlight. It is fluted to allow expansion as water is stored. It can grow to heights of 60 feet and to an age of 150 years. Slow growth and great age are common survival strategies among desert plants. This Palo Verde is only 6 inches in diameter at its base, but may be as much as 400 years old. The Palo Verde is almost always found in the vicinity of the giant saguaro. It has evolved dealing with the same problems. Its green skin is rich in chlorophyll for photosynthesis. Each branch and twig ends in a protective point. The Palo Verde often shelters maturing cactus, a relationship so common it is called a nurse tree. This saguaro seedling survives the winter within the protective canopy of the Palo Verde, where it is 4 or 5 crucial degrees warmer at night than the surrounding desert air. The Palo Verde sometimes dies competing for precious moisture with the saguaro it helped to establish. Some plant mechanisms solve several problems at once. These yucca leaves are defensive spikes and funnel water to the roots. The agave has leaves like bayonets that collect rainfall and defend the seed-bearing shoots 15 feet above. The cholla cactus has the most bristling defenses of any desert plant, but even its defense is not total. Rodents are the most successful and numerous of desert mammals. They were native here long before it was desert. As the land dried out, the rodents stayed. They were able to remain because of habits and physiology that evolved in temperate times, but which were effective in the desert. The antelope ground squirrel is a specialist. He can tolerate a body temperature of 110 degrees for short periods, so he can be active at midday when most competing animals have sought shelter. This exposure may cost him precious moisture, but he can temporarily withstand severe dehydration. Feeding among the cholla thorns, the squirrel is safe from predators. Desert plants form a community of life selected by extreme conditions. The daily heat and aridity are an ordeal fatal for many animals, yet the desert is full of creatures. There has not been time for major physiological changes through evolution, so most animals survive by simply avoiding the extremes. By day, they live 2 feet below the baking surface, where the earth is a maze of burrows. The temperature is halved, and the humidity can be 4 times as great. Tarantulas are primitive predatory spiders. 5 inches across, they are the largest kind in the world. They emerge at the sound of passing creatures, responding many times before finding an animal small enough or close enough to provide a meal. Each morning, this leopard lizard appears. He is cold-blooded. His body temperature may have dropped 20 degrees overnight, and he will not be fully active till warmed by the sun. He is aggressive and quick to challenge another leopard lizard. They bob heads to gauge size and distance. Leopard lizards are carnivores that prey on other lizards, often zebra tails. One sights his prey. It may have been several days since he has eaten, and he may wait as long to eat again. His teeth are small needles, good for catching and holding, but not for chewing or dismembering. Like a snake, he will swallow his meal whole. Within an hour, his powerful digestive juices have dissolved half the zebra tail. He seeks shade and shelter under a creosote bush. 10 minutes of the midday sun would kill him. Hot, arid climates are richer in lizard species than any other zone. They are an ancient order of reptiles as old as dinosaurs. Most are only a few inches long. They regulate their temperatures differently from birds and mammals. Lizards survive by finding suitable temperature zones where they can gain or lose heat with almost as much control as warm-blooded animals. They demonstrate territorial demands in an aggressive display, a spring ritual between two males. It is an assertion of dominance, establishing claim to a few square inches of mesquite bark to attract a mate. The lack of moisture poses few problems for lizards. They do not perspire. Their scaly hide is without pores. Although most are mute, their senses of hearing, smell, and sight are extremely keen. Of all these lizards, the desert iguana is most likely to be out at midday. He can tolerate a body temperature of 115 degrees, higher than almost any other vertebrate. So when animals that prey on iguanas have sought shade, he can be out foraging. During territorial disputes with other iguanas, he can distort himself to appear larger and more intimidating. The Gila monster has hardly changed in 30 million years. Of the 3,000 kinds of lizards, only 2 are venomous, and one of these is the Gila monster. Unlike other lizards, he is slow, but he doesn't need speed to escape predators. Bright colors signal that his bite is lethal. The Gila monster is a success. He has survived the changing climate intact, virtually identical with fossil remains deposited long before there was a desert. Far above the hot ground, spring migrations bring millions of birds through the Sonoran Desert. They are the least adapted to desert life, but their mobility frees them from most of the problems of land-based animals. More birds live in the Sonoran than this parched land would seem capable of supporting. The vulture is a carrion eater, living on the animals that do not survive. The tiny Inca doves choose mates and nest within flying distance of rare pockets of water. The full heat of the day is a problem for the birds. Their eggs would soon be destroyed by the sun without cool and humid nests. These least adapted animals depend for housing entirely on the desert's most highly adapted form of life, its vegetation. The saguaro cactus takes the place of a tree for many woodpeckers of the desert. The saguaro is a soft material, and a nesting hole is made in a matter of days. Gila woodpeckers raise 2 or 3 broods a year and often make a new hole for each brood. The one they abandon will house another bird unable to make a hole of its own. His special ability accounts for the housing of 16 species of Arizona birds. The other cactus that birds depend on heavily for nesting is the cholla. One of the commonest residents is the world's largest wren, the cactus wren. He selects a cactus and claims the surrounding territory. In March, each pair begins to build its nests. They will sometimes construct a dozen, but lay eggs in only one. The other nests are used for roosting or as decoys. This nest will hold the eggs, and the parents are lining it with down. It will insulate the interior from the heat of the sun, so both parents can forage for food. They may never drink. There is enough fluid in their diet of insects. The mourning dove builds a more exposed nest in the cholla. Unlike the cactus wren, their diet does not provide enough fluid, so they gather each day at dawn and dusk to drink wherever they find water, when the eggs are least exposed to the sun. Deep in the shaded interior of the cholla, a curved-billed thrasher feeds its young on the insects that populate the desert. Within 3 weeks, the chicks will fly. Until then, they are reasonably safe in the cholla. By mid-April, thrashers outgrow their nests, but the fledglings are still fed by the parents. The adult cactus wrens must feed their young as well. Beyond the safety of the cholla, the desert is full of hazards for the young each spring. The coyote is only one of the predators of the Arizona upland. He occupies an essential position at the apex of the food chains. He is part of an ancient and enduring system. He is one of the natural controls. It is now mid-April. The desert bloom is the most spectacular in 25 years. It has resulted from a precise combination of heavy winter rains and a cool early spring. In a few weeks, these bright flowers will wither and die, leaving seeds that can endure another 25 years of drought. The annual flower's brief season is the opposite of the cacti's longevity. Extreme strategies that solve the same problems. All of these blossoms serve a single purpose: reproduction. As each plant blooms, its particular species of solitary native bee is hatched in nests underground. The bee may find its nectar nowhere else. The flower may have only one species of bee to pollinate it. Both bee and blossom have evolved as specialists. It is an ancient and exact arrangement. Doves are among the important pollinators of the saguaro blossom. When ripe, its fruit will provide yet another link in the food chain. It scatters 500,000 seeds a year, and all but a few feed foraging generations of insects, birds, and rodents. The seeds are often able to withstand an animal's digestive juices and will pass through his gut unscathed. Part of his daily cache of seeds may germinate in another year. The odds against the saguaro seed ever becoming a mature cactus are 1 in 60 million. The giant saguaro grows from a seed that can await the right combination of heat and moisture for 1 year, 2 years, or even more. To germinate, it must be in the path of a summer cloudburst heavy enough to soak the seed completely for 24 hours. Only then will it grow. At first, the growth goes almost entirely into spreading a root system sufficient to survive the annual autumn drought. Lateral roots develop first. They collect water. At the end of 3 years, the young cactus is no bigger than a pea. At 5 years, it is 3 inches tall. After 15 years, it is a foot high, still too small to store water for a long drought. It will achieve maturity at 70 years. It can grow to heights of 60 feet and live to an age of 150 years. After a summer downpour, it swells as it absorbs and stores a ton of water. With that, it can live 2 years without rain. The saguaro survives because it stores the water soaked up by its surface roots, but the ground is soon again bone dry. Other plants have deeper root systems. The mesquite tree has tap roots that descend 80 feet to deposits of water that fell as rain 2,000 years ago. No known tree sends its roots deeper. Most other plants grow lateral roots in the 2 upper feet of soil. If the water content there falls below 10% for long, some plants become dormant, appearing more dead than alive as they wait for rain. The creosote bush is the commonest and toughest of desert plants. Its root system, one of the most extensive. Beneath a 5-foot bush, they may encompass 900 cubic feet of earth in seeking moisture. It is thought that the creosote secretes a poison that prevents competing seeds from germinating within the compass of its roots. Leaves generate the suction that pulls water from the ground. It begins with the process of transpiration, in which water is evaporated from leaves for cooling. This loss of moisture creates a water deficit in the leaf that transmits a powerful pull to the roots. The leaves of the ocotillo are grown only when there is sufficient moisture in the ground, a new crop each time it rains. As a dry period begins, the ocotillo sheds its leaves. The spines remain, like those of the cactus, for defense and heat loss. In arid zones, a crucial factor in the evolution of leaf-bearing plants has been the need to conserve water. Their leaves are small. Transpiration is less. Suction at the roots is diminished. Waxy leaves inhibit transpiration. They are shiny to reflect the light. Some drop with the onset of drought. Plants like these can outlast the severest dry period. The leaves of this mesquite provide a crop for thousands of harvester ants. They transfer the leaves to storage heaps in underground chambers. These ants are compost gardeners. They use the decaying leaves to fertilize plots of fungus that provide the only food they ever eat. Each species of harvester ant grows a single kind of fungus. They are part of a food chain that begins with sun and water, rises through seed, tree, leaf, fungus, and ant. Next are those that prey on ants. At the top of every food chain is an apex predator. The Harris hawk is one of these, and native to the Sonoran. While their young are fledglings, parents fetch sticks, improving the nest between feeding trips. The chicks are 3 weeks old. At 9 weeks, they will fly with their parents. Within a year, they will hunt alone. But even as they become skilled hunters, they will face terrible odds. In 10 years of breeding, only one of his 30 chicks might live to replace him. Each plant is a sphere of shade and shelter, cooler by a few degrees than the earth exposed to the sun only inches away. As forest and grassland retreated long ago, the plants that remained made it possible for some animals to find comfort and sustenance. Minute quantities measure the margins of survival for all animals that must escape the sun. They all have to maintain a certain range of body temperature. Within it, they live. Beyond it, they die. As rainfall varies, so does the habitat. In the Cabeza Prieta district, 150 miles to the west, conditions are different, the desert more extreme. The average summer temperature is 110 degrees. The rainfall 5 inches. The Ocotillo and the Cholla still occur, but here they are stunted and widely spaced, supporting fewer animals. In search of moisture, roots encompass greater and greater volumes of soil. Seeds find only a rare foothold. The essence of the desert is aridity. Change that, and all is changed. 100 miles northeast of Tucson, there is a rare stretch of permanent water, Aravaipa Creek. Fed by underground springs, the stream is independent of the erratic rainfall. It is a special habitat. "100 feet above the stream, cactus can flourish, but not closer. They do not live where there is a continuous excess of water. Below is a narrow band of life entirely dependent on permanent water. With such an abundance, huge cottonwoods grow. In a single day, each pumps through its roots and transpires at its leaves 200 gallons. On the distant canyon slope, the influence of Aravaipa Creek abruptly ceases. The desert begins again. Some animals live independently of these different life zones and roam freely from one area to another. The vulture gets all his fluid from carrion. He never seeks water and won't even bathe when it's available. High above Aravaipa Creek, there is twice the rainfall, a lingering winter. The saguaro and palo verde give way to grassland and oak thickets. Herds of deer with offspring return each morning from the surrounding foothills to drink. By now it is June, and some of the does are pregnant. Deer need water often and are rarely far from a permanent supply. These are last year's fawns, now grown to yearlings and as swift as their parents. They develop far faster than their predators. Their playful antics build strength and coordination. If their pools vanish in the summer heat, the succulent prickly pear sustains them until the torrential rains of July. Like all cactus, the prickly pear is 90% water. It is poorly defended. Its spines are few, and it is heavily browsed during these dry months. The availability of water stored in the prickly pear has allowed herds of javelinas to extend their range into this arid zone far beyond their origins in the tropics of Central America. Although called wild pigs, they are more closely related to the hippopotamus. These rival males gnash their teeth in mating challenges. Such rituals will occupy each male of this herd till the hierarchy is established. He can then seek out his sow. The javelinas court and choose mates in rituals of acquaintance and acceptance. Feeding at dawn and dusk, they rest by day in communal caves. It is now late afternoon on the desert below. The fledglings of a nocturnal predator await the first feed of the evening. They are the young of the great horned owl. For 6 weeks, they will be fed nightly. By day, their only protection from the sun is thick, insulating down. While the owls wait for night, ravens return from scavenging. The daytime cycles end, and the nocturnal ones wait to begin. Vultures are gregarious mutes. Every night they gather on cool perches in the cottonwoods. The ground begins to radiate heat to the evening sky. The animals that hunt and forage by night are beginning to stir. This long-nosed snake scented, pursued, and captured his prey in just a few seconds. Constricting coils have suffocated a pocket mouse. A sidewinder rattlesnake tests the air for scent. Scorpions scuttle for prey. One waits, his stinger poised. He has struck a grasshopper and bides his time as the poison takes effect. Within 15 minutes, the long-nosed snake has devoured the mouse. The hunt is finished. He returns to the safety of a hole barely large enough to accommodate the lump in his stomach. He will wait underground as it is digested. the owl chicks have been in their element all night. As dawn approaches, their activity peaks. They fan their wings to develop flight muscles. As the sun rises each day in July, it brings greater and greater heat. The cool of the night lasts only a few moments after dawn. The desert is awake. A family of round-tailed ground squirrels has emerged from the safety of the burrow. The mother is wary. Her young are inexperienced above ground, but instinctively careful. It is early. A Mojave rattlesnake returns from a night of hunting. Small, warm-blooded animals are his prime prey. Their maze of tunnels and escape routes affords almost perfect protection. The snake doesn't waste his energy. The ground is too hot for the sidewinder as well. The full heat of the day would raise his body temperature to lethal levels. The Gila monster can tolerate fewer daylight hours. Dawn comes earlier and hotter each day. The sun drives him underground. Six inches above, the air may be 40 degrees less than the surface of the ground. This leopard lizard will stay in the branches of the creosote bush as long as he remains comfortable. He is still gorged from his meal and oblivious to a zebra tail resting nearby. All the lizards seek shade. Even the iguanas have edged in among the creosote bushes, but the shade is not enough. They are panting. By July, there is almost no water left. The humidity of the air is down to 7%. It has evaporated the last remaining pockets of moisture high among the rocks. But there are some animals still out in the heat of the day. The Gambel's quail can get all the fluid they need from the succulent parts of plants. They forage in broods on territorial feeding grounds. During the hottest part of the day, they dart from one patch of shade to another in a ceaseless search for food. The cholla and other plants provide the antelope ground squirrel with fluid and nutrients to supplement his diet of insects and carrion. He rarely needs to drink, but if he does, even a stagnant pool of water more salty than the ocean could sustain him. No other mammal has so high a salt tolerance. While other animals are cool underground, the squirrels are almost the only ones out at midday. They are foraging for seeds. The yearly crop hangs ripe on the palo verde, mesquite, and acacia. Unlike the seeds of spring, they need heat to germinate. They are full of promise, ready for the summer rains. Every July, this saguaro grows 200 fruits containing 500,000 seeds. They feed many birds, including the same doves that sought nectar here and fertilized the May blooms. Most of what remains is soon claimed by insects and other animals. As the fruit falls to the ground, the desert floor is littered with the dry and empty husks. A few seeds are somewhere, waiting for the rains to come. Some animals exploit the desert heat. The turkey vulture has been waiting since sunup for drafts of hot, ascending air to sweep up the face of the cliff. He soars to cooler layers, 500 feet per minute. He will soar all day until the thermals subside at sunset, searching for carrion with the keenest eyesight of any animal. The prickly pear has been living on stored fluid for 2 months. Its reserves are exhausted, and the cholla has all but consumed its supply. Its joints are wilted. For thousands of years, the desert has waited each year for the rain to come. This year's wait is almost over. Masses of moist air have moved inland from the Gulf of Mexico. The humidity is up. The monsoon is coming. Clouds form for the first time all summer, the turbulent cumulus. Their tops reach 40,000 feet into the frigid upper atmosphere. 50 million gallons of water are suspended in a single cloud. In the backwaters of the flooded arroyos, there is a sound not heard in the desert for a year. This spadefoot toad has just emerged from 10 months of hibernation in the baked desert mud. The spadefoots are amphibians and must have water to breed and lay eggs. Their kind first emerged from the water 200 million years ago, but never outgrew their need for it. Miles downstream, the flow is 50 yards wide and 3 feet deep. The storm has passed. A cycle of renewal begins. The toads emerge to breed in this pool. Within 12 hours, their eggs are laid and already are being eaten by the giant diving beetle. Though he may not eat many, he is the first of the hazards. The main peril is evaporation. Unless this pool lasts 3 weeks, the tadpoles that hatch from these eggs will perish. The flood has run its course. The water that remains evaporates. The rest has run off or gone deep underground, where the taproots of the mesquite will find it in the future. Even where the flood ran as a torrent hours ago, little moisture stays at the surface. The next day, water remains where the toads have laid their eggs. They have now hatched, and if their pool survives, so will the tadpoles. The spadefoots did not evolve in the desert. They were here long before. But from the beginning, they had habits that guaranteed their survival. Their cycle of hatching and maturing is faster than any other amphibian. So fast that each year for millions of years, a few have lived. They feed constantly and compete with other maturing creatures like these larvae. The tadpoles will double in size every day. The pool is only 3 feet wide and a foot deep, an oasis surrounded by desert. It is a fleeting habitat where cycles lasting only a few days are played out once a year, perhaps only once in 5 years. Elsewhere, the only signs of rain are a few dark stains in a fine layer of sediment. Rain may fall on this spot once all year. Only 10% of the rain goes into the ground where it is absorbed by plants. The other 90% soon turns to vapor. In the sandy wash bottoms, ants wrestle with the debris that choke their tunnels, sealing them beneath the flood. Each time the ants remain to repeat the process after the next deluge. The 6 weeks that follow the first summer rain is a race against time. The top 2 feet of ground have been temporarily charged with water. The waiting seeds of annual plants must germinate and scatter another crop of seeds before the ground is again dry in the autumn drought. New leaves appear for the first time in a year on plants with tropical origins. Thickets fill with the sound of growing heat, the cicadas. Beneath the ocotillo and the prickly pear, the desert floor is a green glow after the rain. For all but a few days each year, it is withered, dormant, appearing more dead than alive. But that is the way with much of desert life. Beneath the ground, a seed can wait a year at a time or for years on end, a genetic message requiring no water. The saguaro seed and the spadefoot toad both lie buried, observing the same clock of heat, moisture, length of day, till the time arrives. Deserts are climatic accidents, so new they are still populated by colonists and survivors from earlier, lusher times. The soil is filled with the durable cell and fiber of life, waiting for the next cycle to begin. Living things have come to terms with severe and unpredictable conditions. Survival is not a desperate affair, it is a natural process. In the short time the colonists and opportunists have occupied this desert, they have begun to perfect the strategies and mechanisms needed for existence here. Life waits, it races against time, it endures, needing only an occasional rendezvous with the rain.
This program was produced by WGBH Boston, which is solely responsible for its content. Major funding for this program was provided by public television stations. Additional support was provided by unrestricted general program grants from the Corporation for Public Broadcasting and the Ford Foundation, and by grants from Exxon Corporation and the National Science Foundation.